3D renders are cool, but prototypes are real. It's easy to fall in love with a clean, high resolution 3D model. They look sharp, polished, and perfect on screen. But the truth is, no matter how beautiful your render is, it can't tell you how your product will behave when dropped, twisted, assembled, or used over time. That's why prototyping is such an essential step in the product development process. It's not about making your idea look good, it's about making sure it works, feels right, and performs the way you need it in the real world. Building something physically changes everything. Suddenly, you can hold your concept, interact with it, test it, and learn from it in the ways the software simply cannot provide. A prototype is, at its core, a physical version of your idea, but depending on what you are trying to learn, it can take many different forms. Not all prototypes are created equally, and each serves a unique purpose in the journey, from sketch to shelf. One of the earliest and most essential is the proof of concept prototype. This version is all about function. It doesn't have to look good, and it's often made with the most basic materials available. At this stage, you're asking, can this idea work at all? You're testing the core mechanism, validating the interaction, or proving that sensors or component behave as expected. It might be rough, but the insights are invaluable, and it's usually the step where a great many ideas are either refined or abandoned. As the concept starts to take shape, the next step often involves form models. These are typically used to evaluate size, shape, and ergonomics. They may be carved from foam, printed with a low resolution 3D printers, or even built from a cardboard and glue. The point is to get a real feel for how the product exists in space. You're exploring how it fits in your hand, whether it feels too bulky, how it might sit on the shelf, or how multiple parts might relate to one another in the real world. These prototypes are often revised several times to achieve the right feel before any functional elements are added. Once the form feels right, the process moves into a functional prototyping. This is where things start getting serious. Now, you're making a version that actually does what it's supposed to do. It might be working hinge, a snap fit feature, a button, or an entire assembly that simulates the product intended performance. Here, accuracy matters more and materials and fabrication methods reflect that. You might use FDM or SLS 3D printing, or even CNC machining for precision parts, or even cast components like a casting urethane. These prototypes are about testing motion, stress load, wear, and interaction. They help you catch engineering issues early and figure out what works and what doesn't before going too far down the production path. Then, there are appearance models, the prototypes that look like they belong on a billboard or Kickstarter campaign. These don't always function, but they look nearly identical to a final product. They're painted, polished, and detailed to reflect final materials, colors, and branding. They're often used to wow investors, impress clients, or create marketing content while the actual engineering is still being finalized. These models can be a mix of materials and techniques, maybe a 3D printed body with a machine metal accents, and fog display screens. What matters most is that they capture the visual identity of the product. Eventually, you reach pre-production prototype, the final physical test before scaling manufacturing. These are built with production grade material and processes using soft tooling or short run modes. You're now looking for any last issues with assembly tolerances for fit, finish, and packaging. It's also when you start planning for logistics. How will this be shipped, stored, handled, basically fulfillment? Everything from labeling to instructions is tested during this stage. These prototypes often go through quality control checks, certification, or field testing, depending on the product and industry. The way these prototypes are made varies widely from depending on the purposes, right? FDM 3D printing is fast and cost effective for early stage iteration. SLA and DLP offer smooth surface and high resolution for design mockups. And SLS and MGF produce strong functional parts for testing and fit. CNC machining provides the precision and strength needed for moving or load bearing parts, especially in the metal, Unit and casting allows you to simulate injection molded parts before combining the tooling, and for enclosures, brackets, or industrial products, sheet metal fabrication could create a production-ready components right from the start. Each method has strengths and trade-offs in terms of cost, speed, resolution, durability, and finish. And choosing the right one can make all the difference in development timeline. Prototyping isn't just about testing a physical objects, it's also about communication. Whether you're sharing the prototype with your team, your investor, or your manufacturer, having a physical model helps everyone align on what is being built. It eliminates misunderstanding, exposes weaknesses, and allows for a collaboration and feedback in the ways that are nearly impossible with the digital models alone. When you can hand someone an actual object, the conversation changes. Suddenly it's a real. And when should you start prototyping? Well, the answer is simple: as early as possible. The sooner you start testing, the more you will learn, and the more mistakes you will avoid. Prototypes can be cheap and fast, or complex and expensive, but even the simplest one can prevent months of wasted effort down the line. You should also prototype often, as much as you can, to get the perfection. Every version brings new knowledge, and iteration is the key to refinement. The best products aren't built in one perfect attempt. They're shaped, tweaked, tested, and improved through hands-on explorations all over again. Skipping prototyping is one of the riskiest moves in the product development. It might save time or money upfront, but it's almost always costs more later. Missed flaws, poor user experience, manufacturing headaches, they all trace back to skipping this vital step. It's not just a box to check it, it's where great ideas become real and where weak ones are exposed before they hurt your business. So remember, the 3D renders are for scenes, prototypes are for hands. They're messy, they are revealing, they break, they surprise you, but they are also the most important part of transforming an idea into your product. And if you want to build something that works, really works, start building prototypes early, often, and with the intention. That's where the magic happens.